Assalamu alaikum dear students. Today we are going to discuss the limits of trigonometric function. Let f and g be two real valued functions with same domain such that for all x belongs to d, where d is the domain of f as well as g, f of x is less or equals to g of x for all x belongs to d. Then for any point, if limit x tends to a, f of x, and limit x tends to a, g of x exists. That is, if at any point limit of f as well as g exists, then this limit of f is always less or equals to the limit of g of x. Like if we consider here, this is the domain, common domain of f as well as g. Clearly this g is always greater or equals to this f, which implies that at point this a, if limit exists at this point x equals to a, then this limit of f is always less or equals to the limit of g of x. Now similarly, if we come for three functions, which is called as the sandwich theorem, if we have three functions f, g and h such that f of x is less or equals to g of x is less or equals to h of x for all x belongs to d, where d is the common domain of these three functions. And if at any point x equals to a, limit of this f equals to the limit of h of x. So this means that at a common point limit of the two functions h and f exists and are equal, then limit of this middle function, that is g of x, is always the same limit, that is L. That is, if we consider here three functions fx, gx and hx, clearly fx is less or equals to g of x is less or equals to h of x. Now if we consider point a in the domain, now it is given that the limit at x equals to a of f as well as h are same, so definitely this limit g of x at x equals to a should be equals to L. So this theorem is called as the sandwich theorem. Now we will prove prove that cos x is less than sin x upon x less than 1 for x mod x greater than 0 less than pi by 2. We have to prove this, that cos x is always less than sin x upon x is less than 1 when mod x is greater than 0 less than pi by 2. This mod x greater than 0 less than pi by 2 means actually x belongs to open interval minus pi by 2 to pi by 2, because for this, when we consider the modulus from 0 to minus pi by 2, their modulus is always greater than 0 and less than pi by 2. Also we know that in first quadrant, or sin minus x is minus sin x and cos of minus x is cos x. If we consider x means angle in interval 0 and pi by 2, that is in first quadrant, we have to prove this inequality for first and the second quadrants, that is when the angles are in first and the second quadrants. Here we will prove only for the first quadrants, angles in the first quadrants. Now if we consider the point A, here we have a circle with center at origin, and A is the point on the circle and C is the another point on this circle. Now when we join this, we will get a triangle OCA. Now from C, draw a perpendicular OD on OA and produce OC to OB. And from B, draw a perpendicular BA on OA. So clearly we have here a triangle OCA, we have sector OCAO, and we have another, that is bigger triangle OBA. Now the area of this smaller triangle OCA or OAC is less than area of the sector OCAO is less than area of triangle OAB. Now here this triangle is OCA, CD is this altitude, which implies that, and OB is base, which implies that its area is 1 by 2 OACD, that is base into altitude. Now the area of the sector is the angle. If we have here angle and radius is r, then its area is angle upon 2 radius square, that is x by 2 OA square, is less than. Now clearly this bigger triangle is right angle triangle. Its altitude or perpendicular is AB and base is OA, that is 1 by 2 OA AB. Now cancelling OA from each term and cancelling 1 by 2, we simply get CD less than XOA less than AB, where X is the angle in radian. Dividing by OA, we get CD by OA less than X less than AB by OA. Now in bigger triangle, this AB is perpendicular and OA is base, means perpendicular by base is tan x, so AB by OA is tan x, and CD by OA. Now CD by OA is the radius of this circle, which implies that this radius is equals to OC also. Hence CD by OC in this smaller triangle, right angle triangle OCD, it is sin x. So sin x less than tan x. Or we can simply write by dividing sin, it is 1 less than x upon sin x less than 1 upon cos x. Now when we take the reciprocals, so the inequality changes. This means that cos x reciprocal of 1 by x, cos x is cos x, it becomes smaller than sin x upon x less than 1 for all x belongs to 0 to pi by 2. Similarly, we can prove when x belongs to minus pi by 2 to 0. So in nutshell, we can say that this cos x less than sin x upon x less than 1 if 0 less than mod x less than pi by 2. Now if we consider a trigonometric function which is defined at a point, say for example cos x, it is defined at x equals to 0. Similarly, if we consider tan x is not defined at pi by 2. So this means that if we are asked to find the limit of a trigonometric function at a point where the function is defined, then its value is simply, then the limit is simply equals to the value of the function at that point. Like if we consider a limit of cos x at x equals to pi by 2, it is simply limit x tends to pi by 2 cos x is simply cos pi by 2, or limit x tends to a sin x is simply sin a, because if a is real, then sin x is defined at each and every point. Now we have settled out another limit, which is sin x upon x, limit x tends to 0 is 1. We know that by sandwich theorem, fx less or equals to gx less or equals to h of x, and if limit of f and limit of h at a is L, then the limit of this middle function, that is limit x tends to a f of x, is always L. Also by above remark inequality, cos x is less than sin x upon x less than 1. The limit of 1, which is the constant function at x equals to 0, is simply 1. The limit of this trigonometric function cos, it is simply cos is 0, defined at this x equals to 0, it is simply 1, which implies that limit of this first function and the third function is same. Hence the limit of the middle function is actually 1, which by sandwich theorem, which implies that limit x tends to 0, sin x upon x is 1. Like if we consider, prove that limit h tends to 5, sin h minus 5 upon h minus 5 is 1. Now when h tends to 5, this means that h minus 5 tends to 0. Now here, which implies that h minus 5 tends to 0 is actually h tends to 5 means h minus 5 tends to 0. H minus x in angle and in denominator is same, which implies that by above remark, above limit, its limit is 1. Because for this we should have this x angle and the denominator same, and this limit should tend to 0, then we say that its value is 1. So thank you.